Hi.
Hello, everyone. Uh, this is Akshay again, and this is our team TrekDevs. This project milestone was to present and find out some business insights from our data set of locations. So, the first thing that we needed to do before proceeding with business insights was we had to make some changes in our UML. This was because some of the data sets that we had did not have zip codes, which we thought would be the primary key for us to map all the different data sets, tie up all the different data sets together. So what we did was we normalized some of the data sets into smaller tables and had foreign key relationships with that. Because of this, all the data sets were interconnected with each other, and we could get much better insights eventually. So I'm going to go away from here. I'm going to leave this meeting from now. My teammates will continue after this. Thank you.
Hi.
See ya. Okay, so for the first question that I think that was important to address based on the hospital data set is knowing the rating of a hospital, because I think it's important for the user or any patient to want the best quality of care when it comes to your health, because you wouldn't want a bad quality of care, or if you prioritize price, then yeah. So in my select statement, I chose the hospital type, the rating, and the hospital count of the provider ID from the acute care table. And the acute care table, it has a primary key that is the foreign key in the parent hospital table. And in order to get the rating attribute that is in the hospital parent table, I used an inner join with the hospital table's provider ID, and I grouped it by the rating so that we can see the number of hospitals that have a rating of 3, 4, and 5. And also originally in our other model UML model diagram, we only had one big hospital table, but one of the changes that we made was creating 4 other child tables using the provider ID as the foreign key, and we grouped it by the hospital type, such as acute care, children's hospital, psychiatric hospital, and also critical care hospital.
You hear me? Also, next, maybe I'll talk about my business question. So my dataset is the air quality table. And for my question, I think it's interesting for some user to, like, if they are interested in some places that have more of a better nature environment, so like more water resource and better air quality. So my question is, among the cities that have that have a high water resource, like what percentage is those cities that has better, like good air quality? So basically, I have to use inner join of the air quality table and the water resource table. And after the join, we use different filters to get a like percentage ratio. So that like the result is 40%. So it's like the places have more water resources, likely that those places have better or good air quality.
Awesome. So I'm Neil, and I had mostly the population density data set. And besides having to do a little bit of normalization to the data, as discussed, my business insights are to check out how the population of an area might be. So, for example, my query is the 10 least populated places according to the housing density. So, if you're trying to get away for travel or something and you don't want to go to a giant, big, bustling city and you want to get away, basically I've checked it out, and there's a few places that are pretty open and expansive, and they have lots of they have very few people. So yeah.
Hi folks, this is Peter Loda. I'm going to talk about normalization because that's what I've spent pretty much all of my time on. I took on the normalization of the location information that was going to be used by all the other tables, and so read in a locations data set from Simple Maps, read that into a temporary table, and then created some it had zip codes and cities and states and counties and things like that. So it created some child tables like cities, states, counties, and latitude, longitude pairs. Then created a copy of the temporary or the staging table, and then used that as sort of the zip, made that the zip code table. From there, altered the tables so that, and then used update, select, inner join type commands to normalize it, to normalize the tables, and then of course altered the tables later to add the foreign key constraints. Did that for both locations as well as for homicides, with incidents, and then incidents I think ended up with, I think there were like 4 tables: incidents, agency, perpetrators, and victims. Did run into a lot of challenges with it. It's there's a lot of data from the homicides data set. There's about 640,000 rows. But all in all, the entire normalization process for all of the data takes about 10 minutes currently, without really a whole lot of optimization other than the use of some of index, or creating some indexes in front of the joins. And other than that, I will my queries will be submitted with the rest. So just need to take some time today to do that. And that's pretty much what I have.
And I'm glad Peter was able, he did most of the normalization, and thank God we spent most of our time doing normalization. Yeah. So yeah, that is part 3 of our project, doing the business insights. We covered air quality, answered questions about air quality, and also population density and hospital data. And yeah, thanks for watching.